Hi, it's me, Jazzy. I'm back with another tech-related video, and today I'm taking a look at another product from Miniware. Yes, you may remember we took a look at the DC electronic load and the smart digital monitor recently. Well, Miniware have very kindly sent me over the MDP-P906 power supply, which promises 300 watts, which seems amazing in such a small device. So thank you Miniware for sending this over. Let's get it over on the bench and see what it can do. Right, so this is the MDP-P906 digital power supply, and this can work on its own or it can work in conjunction with the other Miniware items. We've got our DC load here and our smart digital monitor. So we're going to see how this works both on its own and with the other units. Now this is really cool because it's such a small size. They promise a lot from it, and we're going to give this a good testing. So they reckon it's got ultra low ripple and noise, less than 250 microvolts RMS or 3 millivolts peak to peak, so we can check that on the scope. It's got a wide input voltage, so you can input DC 4.2 to 30 volts, and USB-C you can input up to 20 volts. It gives you an ultra high speed transient response of less than 4 microseconds, and the power output on this is impressive for such a small unit. 0 to 30 volts, 0 to 10 amps, 300 watts max. So again, we can give that a good testing. So let's see what we get in the box. Enough looking at the box, let's see what's in the box. Again, we get the nice acrylic case. I do love that inclusion with the Miniware items because it gives you something to keep your unit in and transport it if you're going out to some sort of maker meet, or you're just going away somewhere and you need to take a bit of test gear with you. So you've got your instruction manual here, which is a similar format to the other Miniware items, multilingual. So I'll have a read through that, and we've got some QR codes on the back as well, which takes you to all these various things. So designed by eDesign, that's the parent company of Miniware. There's loads of cool stuff that they do. So let's have a look what we've got in here. Okay, so we've got our little card as usual, so a warranty card. That's all good, a bit of foam, and here is our power supply. The MDP-P906. Wow, this is little for a 300 watt power supply, isn't it? Wow, look at that. And I believe we've got some cables in the bottom here. And we get, again, some test leads, which look like they may be silicone, possibly. And gold plated, which is nice. So we've got gold banana plugs and crocky clips. So you've got those, that's a nice inclusion. And then we've got our power supply. So let's have a closer look here. So we've got our outputs here. We've got a little display, set, menu, run and lock. And we've got a little rotary encoder on the corner there. On the back, we've got our power input, which is either DC barrel jack or USB-C, but it does warn you there to only use one input at a time. So you can do up to 30 volts on the barrel jack or 20 volts on the USB-C. It will do PD. And we've got a little connection there, which is the connection for the smart digital monitor. So we've got a cable that goes from this into the power supply. And of course, this does integrate nicely into the stack. So you can stack them up how you want because they've all got the locking feet. So you could have it like that with the power supply at the bottom, or you could have the DC load at the bottom, have the power supply there, however you want to do it. It's really cool. As a whole stack, it does look very, very cool. So we'll be able to hook up our smart digital monitor to the power supply there. And we'll be able to hook up the DC load, and we can do some testing with the whole stack. But what we'll do first is we'll have a look at the power supply module and how it works on its own, and then we'll try it with the rest of the stack. This is just a standard USB-C 5 volt 2 amp, and I believe we can just press run. There we go. Here the fan running. We've got a fan on the bottom there, a little fan there, just runs a little bit when it turns on. That's good, that will keep it cool. It's all very nicely designed, as you would expect from Miniware. So you can see the inputs on the bottom there. So DC 4.2 to 30 volt, 14 amp max, and USB-C, it'll do 20 volts, 5 amps max. And then the output, as we know, is 30 volts, 10 amps. I like the rotary encoder lights up on the corner there, that's quite nice. Now this is flickering on camera, that's just caused by my camera, it's not actually flickering. So we've got our display here, so that's the voltage it's set to, which is currently 30 volts, which is its maximum. It's telling me that it's off there. This will also display the mode that it's in, so whether it's in constant current or constant voltage mode, that will come up there. Shows your current limit there, which is set to 1 amp at the moment, and it's not putting out any power because it's not doing anything, it's just idle at the moment. So if we go into the menu, you can see it says 1 of 5 there. You change that with the rotary encoder, so input voltage, input current limit, temperature, and that's your networking for communication with your smart digital module. So nice and easy there. Long press on menu will show your input current limit, your TX and RX address for comms, current limit mode, which is set to normal, that's your sound, how loud you want the beep, that's your program output, which you can change the program much the same as you could with the DC load, and you can change your language there. All fairly self-explanatory, and much like the DC load, the controls are very familiar from one Miniware product to another. So if I want to change my voltage there, which is highlighted, you can see if I rotate the rotary encoder, that's doing my fine adjustment, and if I want to do coarse adjustment, you just hold down set and do that, and you can see it moves in greater steps. So if you want to move down or up much faster, you can do that. Run and lock will obviously start and stop the output, so if I press run, that will immediately put out 16.2 volts that I've got that set for. You can see the blue light there indicating that it's running, and also the ports light up. That's quite a nice touch, I like that. Same as it does on the DC load. If you want to lock the parameters, you just hold down the run lock button and you get a red light there, shows the parameters are locked. Hold that down again, turns that off, press that again, and it stops. So very, very simple to use, very easy to use. Okay, so let's do a couple of quick tests then. So first of all, let's bring in my multimeter. Let's see. So this will put out up to 30 volts. So let's go up to 30. 300 watt power supply, literally in your hand. This is very cool. I do like this Miniware stuff though, because I just like the form factor of it. It's just cool. So we've set this to 30 volts. So if I set this to run, here we go, 30 volts. Bear in mind, this is a 5 volt USB-C supply going into this. You could run this off a battery pack and get 30 volts DC for testing stuff. This is so cool if you're going out to a maker meet or something, or you want to do some testing, or you want to go out and do a repair and you need a DC power supply to do some fault finding. You can just take this with you. It's nice and easy. You can just slip it in your bag. You've got the cool little cases that come with it, so you can just transport and store your Miniware modules. I like the idea of the cases. I think that's quite cool. So yeah, 30 volts DC off of this. All right, so what we're going to do is we're going to put it on a load and we're going to load it up. Let's get the rheostat. Okay, so we're all set up then to test the Miniware power supply. Got the rheostat in position there. We've got a meter to measure current and a meter to measure voltage. The only limitation I think is going to be my bench power supply, because to max out the Miniware we need to put in 14 amps at 30 volts, and my bench power supply will only do 10 amps at 30 volts. We can try. You can't put more than 30 volts into the Miniware, otherwise I could have just put more voltage. But let's see what we can get. Anyway, let's bring the rheostat down. So we're still at 30 volts, give or take. We're coming up on 5 amps there. Okay. And the Miniware is giving us, what, 170 watts, just over. 7 amps. Okay, let's keep going down. 8. I don't think we're going to get much more out of the bench power supply. Rheostat's getting hot. Yeah, oh, there we go. Yeah, bench power supply's gone. It's gone into protection mode because the Miniware is asking it for more than it can deliver. So the limitation is not the Miniware, the limitation is my bench power supply. Couldn't supply what we needed there. Let's cut that there and go back to the highest I can get without the bench power supply cutting out, which is 30 volts at 9.5 amps, and the Miniware is giving us 278 watts. So we're nearly there. We couldn't quite max it out at 300, but I don't think it'll have any problems. If it'll go to 278 watts, I can't see why it wouldn't go to 300 watts. I might run this experiment again in the future when I've got a bigger power supply. I have got one on the way. You can see if we look at the thermals there just after the experiment that the rheostat was sitting at well over 100 degrees. The Miniware cool and calm at 33 degrees. Now what we can do is, while we've got all this stuff set up, let's have another go and see if we can get the 10 amps. Let's see if the Miniware will give us the full 10 amps. So I've revised the setup slightly and I'm running at a lower voltage so we can see if we can get the current. Yeah, and indeed we can. Yeah, look, just over 10 amps. That's absolutely fine. We're only at 6.5 volts because that's a limitation of my bench power supply, not the Miniware. And the Miniware is only setting at 66 watts. So if we could give the Miniware more juice, I'm sure it would give us the 300 watts, no problem. And again, the Miniware is not even getting particularly hot. We maxed it out as much as we could at 278 watts. I see no reason why this wouldn't go to 300 watts. And I'll reprise this test as well when my bigger power supply arrives. Okay, so I'm set up for some noise tests here. I've got my scope probe on the output of the Miniware. They claim it's ultra low ripple and noise, and they reckon 3 millivolts peak to peak. So we're set up here. Now the noise you can see on my scope, which is about 20 millivolts, is caused by the switch mode bench power supply that is supplying the Miniware. Because you can see as I'm increasing the current here, the noise is not really changing appreciably on the scope. So we're up to about 8.5 amps, 8.6, nearly 9 amps. The noise hasn't really changed that much. The noise you get out of the Miniware will depend on what you're putting into the Miniware, as we're going to see. So as I back that off, there's not really a lot of change. And I switch the Miniware off, still not much change. That noise you're seeing on the scope is the noise coming from the switch mode bench power supply that we've got going into the Miniware at the moment. There's also going to be a lot of background interference from stuff that's running in the studio. So I'm going to repeat the same test, this time using my Farnell linear power supply. You can see much less noise than the switch mode, much cleaner supply. So switching on the Miniware, noise doesn't really change that much. So let's try increasing the load on it. We can go up to near enough 3 amps on the Farnell power supply. Otherwise it's just going to limit. So going up, and again the noise is not really changing that much. So yeah, at 10 volts we've got 2.7 amps, not really much appreciable in the way of noise. A lot of that is going to be coming from just background interference of stuff that's running in the studio. There's tons of stuff, there's lighting, there's equipment, there's computers. But all I can say is from the tests that I've done, it appears the Miniware is not adding any appreciable noise to that. Okay, so we've taken a look at what it can do. We've seen it definitely will do 30 volts. It definitely will do 10 amps. So the great thing is we can now use this to hook up our smart digital monitor, because the digital monitor comes with the lead. Here we go. So we have the lead that comes with this. So we can hook this up, which is rather handy because we've got micro USB on the back of here. Okay, now this just plugs in to, we've got a dedicated port on the back of here. That's rather handy, I like that. Nice, so just need one input into here now. I'll go back to my USB-C now we're done with the load testing, so we can power this up now. Nice, I like that. See, now it's starting to work together. So config. Now let's see if this is the same as it was with the DC load then. So auto match. So we need to go to confirm. There it is. There we go. Great. So if I come out of there, so it's now seeing the power supply here, P906, and it's telling me that it's putting out 0 volts, 0 amps, 0 watts currently. So if I set this to run, even though we've got nothing plugged in, if I set this to run, yeah, you can see we're putting out 9.96 volts. This is pretty handy, I like this. Okay, so let's see if we can also pair with our DC load. Here we go. If I turn this on, okay, now we can hopefully pair this. So let's go to config. So we want auto match, confirm, long press on menu here. There we go, and set. Now we've got two. Fantastic. So it knows we've got a P906 and an L1060. See, this is where it's all starting to come together now. So the great thing is the smart digital monitor is now being powered off of the P906. So we no longer have that issue that we had of this losing the pairing with the DC load. So as long as there's power going into this one, then this one's going to be powered. So you can see we've got two devices now. So if we go back to the main screen, we've got our P906 and we've got our L1060. Fantastic. Right, so I reckon while we've got the whole stack set up together, it's a great opportunity for us to test Miniware with Miniware. We can use the DC load to test some of the parameters of the power supply here. So yes, if we go into our DC load, which is the L1060 here, device, swap to that one, and we can go info and more. I do like the fact, actually, I must mention now, when you have more than one unit and these start to become populated, that's when the smart monitor starts to really make sense, because you can monitor all your different devices. So if you had other Miniware devices that were doing other various things, you can keep an eye on all the stats there on the monitor. Yeah, so let's go to more. We can do our, let's tab across to our dynamic test here, which will flip between 1 amp and 0.3 amps. And we'll be able to see what the power supply is doing there. Okay, so the DC load is now testing the power supply. We can see the stats changing here on the DC load. You can see the voltage flicking, and the power supply is flicking between 1 amp and 300 milliamps, but it's going so fast that the display can't quite keep up. Okay, so let's do a 5 amps constant current mode on the DC load. So when we run, you can see the stats on the smart monitor there. I like this. This mode's great because you can see at a glance what they're both doing. The DC load's on constant current mode at the moment. It's 4.994 amps, 0.2 volts. So if I reduce the current down, you can see it coming down on both there. The DC load is bringing the power supply down. There you go, to 2 amps. in constant current mode. Yeah, we could do the same thing in constant voltage mode if we wanted to. We could run a constant voltage. It's running at 12 volts. So if I bring the DC load down, it'll bring the power supply down. Now, what I really love about the Miniware stuff is the potential for doing experiments and testing almost anywhere. This whole setup's running off a power bank here. Now, with the smart digital monitor on the top, you can also set it. If you press Info Grid long press, you can get this larger grid screen, and you can also get a big screen of what your device is doing. So there's the L1060, that's our DC load down there, and you can cycle through, so you can get another display here, which I love. This is great because you've got the DC load and then you've got the power supply underneath it, so you can see exactly what it's doing. It's not putting out anything at the moment, but if I turn it on, so you can see what it's doing. It's putting out about 10 volts, which is confirmed there by our meter, and it's putting out 0.4 of an amp, which we can see there. This whole test is running off a battery pack. That's what I love about the Miniware. You could take this out to your maker group or whatever. It's just so handy. And this is literally just running off a USB-C from the power bank. And we are able to get from that down a bit further. This is pretty impressive. At the moment we're pulling 8.5 volts at about 3 amps, 25 watts, all off a USB connection from a power bank. Pretty awesome. Well, as we've seen, the power supply is really good. I think we'll have no problem doing 300 watts. We got it close. I'll do a retest when I get my bigger power supply, and I think that'll have no problem getting up to the full 300 watts. We've seen it'll give 10 amps. We've seen it'll give 30 volts. Even on a battery pack on a USB-C connection, we can get 30 volts from it. And as we saw, we had no trouble getting up to nearly 5 amps. So if you're out somewhere and you need to do a quick test of something or an experiment, and you're running off a battery pack, or you've only got a USB-C connection, I think it makes it really useful. And of course you can run it off the barrel jack if you need a bit more grunt, as we've seen. It works great on its own. It's 300 watts in your pocket. You've just got to put some power into it from a source. I was using a switch mode power supply, which wasn't quite powerful enough to do the 300 watts. As you saw with the noise test, there was much less noise, virtually nothing, when we used the linear power supply. Most of that interference was coming from things in the studio here. There's so much equipment and lighting and stuff running around that anytime you switch a scope on, there's always going to be some background noise. And I think to some extent, the rheostat, the big one we were using, was acting like a bit of an aerial in that respect for picking up interference. So yeah, the Miniware P906 power supply, really good on its own and really awesome as part of the rest of the Miniware range as well. So I'm really pleased I got the chance to try the power supply. I've loved testing with this thing, and it's amazing what it can do for its size. Another cool little bit of gear from Miniware. Well, there you go, the MDP-P906 power supply from Miniware. Well, it's a rather impressive little bit of kit, isn't it? It works great on its own. No doubt it can give the stated 300 watts. And we've seen it definitely gives you the 30 volts. It definitely gives you the 10 amps. And it's quite impressive for such a small bit of kit. You've got the fan on the bottom there, which does come in from time to time, but it's pretty quiet. It's not too intrusive. It works in the same way as the rest of the Miniware modules with the display and everything. And as we've seen, it integrates really well into the rest of the stack with the DC electronic load and the smart digital monitor. I like the fact you can power the smart digital monitor off the back of the DC power supply, which means you only need one USB cable in there. My only query really is the fact that when this loses power, if this does lose power for any reason, your smart digital monitor again loses its settings. I like the ecosystem. I think the products are really well made. They feel really solid and it works really well. The whole lot works really well together. I was impressed with the last two products from Miniware, and this one's no different. I think it's really well made and it works really well with the other units in the Miniware range. If you fancy checking out the MDP-P906 for yourself, I'll leave the links in the video description down below, and big thanks to Miniware for sending this one over for me to take a look at. So I hope you've enjoyed today's video, taking a look at the Miniware power supply. As always, massive thanks to everyone for watching, sharing, liking and subscribing, and big thanks to all of my YouTube members. Don't forget you can also support me on Patreon and buy me a coffee, which helps to support the channel and keeps me making more of those cool videos. I'll be back soon with some more tech related videos, but in the meantime, take care and I'll see you on the next one.